Good morning. I welcome all of you for this video lecture. Dear students, in the last lecture we have seen what is binomial distribution, what is its probability mass function, and also we have discussed the situations wherein binomial distribution arises, and in addition to this we derived a recurrence relation for successive probabilities of binomial distribution. Okay, so we will continue the discussion on binomial distribution, and today we'll see numerical example in which probabilities of certain events are computed. So let us start with this example. Let me read out. Let X has binomial distribution with parameters 5 and 1 divided by 3. Compute number 1, probability of X is equal to 0, probability of X is equal to 5, and probability that X lies in between 2 and 4, where 4 is inclusive and 2 is exclusive. Okay, so we have given the values of parameters of binomial distribution. There are two parameters, n and p. Here n is given as 5 and p is given as 1 divided by 3, and we have to compute probabilities of 3 different events. These 3 events are X is equal to 0, X is equal to 5, and X lies in the interval 2 to 4, 2 open and 4 closed. Okay, so we will try to find out the probabilities. First of all, we'll write the PMF. Since X follows 5, 1 divided by 3, the values of n and p are written. The PMF of X is given by, now in the PMF we have plugged the values of n and p and q also. Q is 1 minus p. So ncx means 5cx. P raised to x means 1 divided by 3 raised to x. And q means 1 minus p, that is 2 divided by 3 raised to n minus x. N is 5. And here x takes values from 0 to n, means 0 to 5. Otherwise this PMF is 0. Okay, so we have plugged in the values of parameters in the standard probability mass function of binomial distribution. Now to compute x is equal to 0, put small x is equal to 0. So it becomes 5cx means 5c0 into 1 divided by 3 raised to 0 and 2 divided by 3 raised to 5. आता या ठिकाणी 5c0 हे जे कॉम्बिनेशन आहे त्याची व्हॅल्यू येते 1. NC0 is always equal to 1. Anything raised to 0, it is also 1. So first two terms, that is 5C0 is 1. 1 divided by 3 raised to 0, it is 1. So it is 1 into 1 into 2 divided by 3 raised to 5. And that turns out to be 2 raised to 5 divided by 3 raised to 5, and that is 32 divided by 243. Of course, you have to compute this with the help of calculator. Even you can simplify this quotient further using calc, and you will get the value in between 0 to 1. Okay. Next event, x is equal to 5. So probability of x is equal to 5. Now put small x is equal to 5. It is a 5C5, 1 over 3 raised to 5, and 2 divided by 3 raised to 5 minus 5, that turns out to be 0. Now again 5C5, NCN, it is always equal to 1. And 2 divided by 3 raised to 0, it is also 1. So the term left out is 1 divided by 3 raised to 5. 1 divided by 3 raised to 5, and it is equal to, here is a printing mistake, please correct it. It is not 5 divided by 243, it is my mistake, I am sorry for that. It should be 1 divided by 243. It should be 1 divided by 243. It is my mistake and I am sorry for this mistake. Please correct it. It is, second probability is 1 divided by 243. Okay. Then third one, probability of x strictly greater than 2 and less than or equal to 4. तर एक्सच्या व्हॅल्यूज 2 आणि 4 मध्ये एक्सक्लुडिंग 2 नाही इन्क्लूड करायचा. इट इज स्ट्रिक्टली ग्रेटर दॅन, म्हणजे कोणत्या व्हॅल्यूज राहतात मग 3 आणि 4. x strictly greater than 2 and less than or equal to 4 means there are only two values, possible values left out for x, and these are 3 and 4. So probability of x is equal to 3 plus probability of x is equal to 4. We can add these probabilities. याचं कारण काय, तर शेवटचं जे एक्झॉम होतं प्रोबॅबिलिटीचं, कोणतं एक्झॉम आहे ते, फायनाईट ॲडिटिव्हिटी, म्हणजे दोन म्युच्युअली एक्सक्लुझिव्ह इव्हेंट्स असतील तर त्यांचं युनियन म्हणजे त्यांची ॲडिशन असते. सो एक्स इज इक्वल टू 3 or 4 or means union and they are mutually exclusive. X can either be 3 or 4. That's why we have taken the addition. मग आता एकदा एक्सची व्हॅल्यू 3 ठेवा आणि एकदा एक्सची व्हॅल्यू 4 ठेवा and compute the probabilities. I have computed it already and quoted the result directly. 5C3, 1 divided by 3 raised to 3, 2 divided by 3 raised to 2 plus 5C4, 1 divided by 3 raised to 4, 2 divided by 3, so it is 50 divided by 243. So in this way, we can compute probability of any event of binomial distribution if we know the values of parameters. So when the values of parameters are known, the distribution is completely specified. That means we can compute probability of any event. Okay, so the only condition required is to know the values of parameters. We will solve similar kind of problems in the practical session also. Now here one more example, but it is of different kind. The difference is that in the previous example, we are given the values of parameters and asked to compute probabilities of various events. Here the example is different one. What is that? We are given the mean and variance of binomial distribution. I'm sorry, you are not still introduced to mean and variance, so I will skip this example and we will move on further to study first of all what is mean and what is variance of binomial distribution, and then we will come back to this example. Okay, so I think we should stop here and we'll start with this new subunit in the next lecture. Thank you for listening this video lecture. See you tomorrow.